morning and welcome to today's lesson. And in today's lesson, we're looking at a class of lipid which we call steroids. We've been doing different types of lipids. We've covered the fatty acid, we've covered the triglycerides, we've also covered the sphingolipid, we've also covered the prostaglandins. But today we're going to cover a kind of lipid which we call the steroids. So what are steroids? That's the question that we are going to digest this morning. So what are steroids? Steroids, ladies and gentlemen, these are lipids that are made from 3 6-membered rings and 1 5-membered ring fused together. So it is made up of 4 rings, and these 4 rings, they are organic rings, which in which 3 of them, they are 6-membered and 1 is a 5-membered ring. So let us look at the structure of steroids in general. And in particular, we're going to look at the structure of a steroid which we call cholesterol. Why cholesterol? It's because cholesterol is the most abundant and common form of a steroid. And on top of that, cholesterol forms the precursors of all kinds of steroids. It is the precursor, or it is the basis upon which other steroids are built. So most of the steroids that you're going to find, regardless of the name, they will always take the form of a steroid or of cholesterol, which is the most common example of a steroid. So let us look at the structure. So like I said, they are made up of 4 rings that are fused together, in which 3 of them, they are 6-membered. So here is the structure, and I've labeled them using letters so that we see which one of those are 6-membered ring and which one of is a 5-membered ring. So we have A, B, C. So A, B, C, these are 6-membered rings. If we want to prove that, we can just count. When we count the number of carbons from in each of these rings, A, B, and C, you're going to find that you are going to have 6. So let's start from A. We have 1, 2, 3, 4, 5, 6. This is a cyclohexane. Even B, you're having 1, 2, 3, 4, 5, 6, 6. Then C, cyclohexane, you're having 1, 2, 3, 4, 5, 6. So in A, B, C, these are 6-membered rings. How many are they? There are 3. So you have this one cyclohexane fused together. Then you have another one which contains this is cyclopentane. It contains 5 carbon in it. It's a ring but contains 5 carbon. So when we count, it will be 1, 2, 3, 4, 5. So D contains 5 carbon. So I want you to notice 3 things about the structure of a steroid. 3 major things. Number 1, when we start numbering, we start from here. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So these carbon, these rings that are fused together, when we count them, we are going to have a total number of carbon 17. Then I want you to take notice that at carbon number 17, there will always be an alkyl halide which is attached, which should contain a maximum a minimum of 12 carbon and a maximum of 26 carbon in it. So it will have a long chain of hydrocarbon. That's why we are seeing the Ara group there. So at carbon number 17, there is an alkyl halide which will be attached. Then at carbon number 13, you are going to have either a methyl group or any other functional group. At carbon number 10, you are going to also have a methyl group. That is, if you're talking about cholesterol. Then the most important thing is that at carbon number 3, you are going to have either an hydroxide group or a carbonyl group. A carbonyl group, you are going to have a double bond which is attached to a carbon and also attached to the oxygen. So in this case, we have the OH. So regardless of any steroids that you're going to come across, the only difference will be the substituents that are attached at carbon number 17, 13, and carbon number 10, and also at carbon number 3. That will determine the type of steroids that you're going to have. If, for instance, if you're talking of testosterone here, instead of having a long chain hydrocarbon, you only have an OH. So that's the major difference. So that is the basic structure of cholesterol. Try to draw this structure and practice as many times as possible so that you get used in terms of drawing What's important is just drawing these four membered four rings that are fused together. Once you get acquainted with that, the rest they are not difficult for you to do. So let us look at some of the functioning of steroids. So steroids, the first function of steroids that I'm going to discuss with you this morning is that steroids are used in salt balancing. They are used in salt metabolizing. The next function is that steroids are used as precursors of hormones, meaning, like I mentioned earlier, I said uh, most hormones or most steroids they form hormones, and most of them they come from if you're talking of animal steroids or animal hormones, we're talking they mostly come from a steroid which we call cholesterol. That's why I'm saying they are precursors of hormone, so they can undergo chemical reaction within the body to produce different types of hormone. They are precursors of hormone. Then the other thing is that most steroids, ladies and gentlemen, they form the parts of the cell membrane, and also they are the components of what we call a lipoprotein. Lipoproteins, these are clusters of lipids, of fatty acid mixed with a certain protein which we call the adipoproteins. So the adipoprotein wrapped in with the fatty acids and other components that are used for transporting of fat of insoluble lipids. So since most lipids are hydrophobic, they are unable to dissolve. How are they transported? They are transported by the use of what we call the lipoproteins. So the steroids are also found in that cluster in that core of lipoproteins. So that's why we're saying they are lipoprotein components and also form the cell membrane. Ladies and gentlemen, the other thing I want to talk about is how we can classify these steroids. So steroids, you can either have an animal steroid or a plant steroid. So what I've done, I've separated them. I've got where we have animals and plants. So animal, we're talking about animal steroids, and this side I'm talking about plant steroids. So, for instance, one of the the example of an animal steroid that you can find is what we call testosterone. Testosterone. Take note of the spelling. Sometimes pronunciation of these words, biological words, can be tongue twisting. So this is what there is a steroid or an hormone which we call testosterone. So testosterone, what it does, this is a male hormone which is responsible for the developing of male secondary sexual characteristics. It's a sexual hormone which is responsible for a man developing muscles, broad chest, voice. It is because of this. Then we also have another steroid. In particular, it's a hormone which we call cortisol. So cortisol, it is a stress hormone. It is a chemical that is released in the blood when you are stressed and make you feel that anxiety. Then we also have progesterone. So progesterone is also an hormone which is a steroid which is responsible for developing of uh, uh, female secondary sexual characteristics. It is this. So this hormone is quite important. It is responsible for developing of breasts and widening of the vagina, broadening of the hips. Then we also have another steroid which we call estradiol. Estradiol is also a female hormone which is also responsible for menstrual cycles, and also it is mostly produced uh, during menopause. It's more active, but during the lifetime of a reproductive lady, of a reproductive woman, so to say, it is most active as well. Then we also have estrogen. Estrogen is also a female hormone which is responsible for developing of female secondary characteristics. Then we also have plant hormones or steroids which we call, for example, we have stigmastano. So stigmastano is also a plant hormone. Then we also have stigmastro. Stigmastro is also a plant steroid. Then we also have cystestro. So cystostro can either be in form, you can have a alpha 1 cystostro, or you can have a beta 1 cystestro. So all these, they are different types of plant hormones. And most of these, they are responsible either for germination and also the opening and also enclosing of flowers during the day and at night. So these are the different classes of steroids.